Hi guys, welcome to the classroom. Today we're going to cover one of the most powerful wind systems in the world, the tropical cyclone, also known as the hurricane. So I built up the whiteboard like this, so we are seeing it from above over here, USA and tropical high here, Mexican Gulf. In the middle I sliced the hurricane in half, so we are seeing it from this side perspective, and also the Atlantic Ocean is like sliced into half. Over here we have the West Africa seen from above, tropical high up here and the intertropical convergence zone down here. So that's the layout for today, all right? So where are we? So the equator is down here, and the formation of the hurricane is actually not on the equator, but 5 degrees north or south of the equator, because the Coriolis effect is not strong enough right on the equator to drive this really powerful low pressure that has to spin around itself. So 5 degrees north of equator, the Coriolis effect is strong enough. So West Africa, the ground is heating up and it causes the air to rise up into the atmosphere. It will cause the building of cumuli clouds, and if the wind is quite calm, these small cumuli clouds can build themselves up higher into the atmosphere into cumulonimbus clouds, like thunder clouds. These thunder clouds, under the right circumstances, they will be pulled out over the ocean towards the west. Why are they being pulled out? Well, we have the tropical high up here and we have a low pressure down here, and the wind will always go from the high pressure to the low pressure, but the Coriolis effect is driving this wind towards the west. So the prevailing wind right here is always in the western direction. We call these winds the trade winds. Sorry about that. So these trade winds will then pull out the thunderclouds. The trade winds also causes the surface water to go in the same direction as the trade winds. So the surface of the seawater has been heated up by the sun, and this heated seawater will then go west. So we have like this wedge of hot water in the western direction. So the seawater will get warmer and warmer the further west we get. Okay, so the thunderclouds has now moved over the ocean, and it's found really hot seawater above 26 to 27 degrees or 79 degrees Fahrenheit. What happens? Okay, this is what happens. This hot seawater will then evaporate into the air and causing the air to get moist and humid with a lot of water vapor in it. The water vapor is then sucked into the low pressure and it rises into the air. And inside the cloud there's a condensation process going on. And this process is really important in understanding this weather system, because this is where it gets its energy from, and this is why it's accelerating. It releases energy. It releases 0.5 degrees Celsius every time the air rises 100 meters into the air. So it gets warmer, and when it gets warmer, it gets lighter, and then it rises up even faster. When it rises up faster, it will also suck in air faster, and this warm, moist air is then giving new energy to the condensation process. So this weather system is accelerating as long as it's over hot seawater. And it's not only accelerating the wind speeds, it's also so this low pressure is sucking in wind, but it's also sucking up the sea surface, causing the sea surface to rise. So we've got like a storm surge building up underneath this weather system, and when it hits land, this storm surge is really a disaster. It's really a big problem. So you got the wind speeds from the hurricane, but you got the storm surge as well. So it's like a double-edged sword hitting. So now we got the tropical cyclone formed, and then the trade winds will pull it west. Before it hits the coastline, this high pressure has to be taken into consideration. This high pressure is turning around in a clockwise direction, and the low pressure has a western pathway, right? but the high pressure will then take the low pressure and deflect its pathway. It can take like a pathway high up north or a lower pathway, and it's the high pressure that determines which way it's taking. If the high pressure is situated further out into the ocean, it will start the deflection even earlier, and then the low pressure will go up north, and it might even stay over seawater and not reach the coastline at all, but just have a pathway up like this. So when this weather system hits land or it hits colder seawater, what happens? Well, it totally falls apart, because when it's over land, there will be no hot water vapor going into the cloud, and if there's no hot water vapor, there will be no condensation process, and without the condensation, the heating of the air inside the cloud is just dying out, and that's why this whole weather system is falling apart when it reaches land or it reaches colder seawater up north. Okay, my phone is ringing, guys. I gotta go.